Children, let's see some terms related to circle and the formulas, definitions. What exactly we are going to see is nothing but arc, sector and segment. So very first to start off with is nothing but arc, right? I've given you on what things we are going to learn on: figure, definition and naming, types and formula. What exactly an arc is, children? So let's understand the definition first. The length of an arc of a circle is the distance along the curved line. The length of an arc of a circle is the distance along the curved line. So if I were to say what exactly an arc is, say this is my center point O, this is my center point of the circle O. From here to here, if I have to say A, B, then this portion is nothing but my arc. This portion is nothing but my arc. The length of the arc of a circle is the distance along the curved line. It is the distance along the curved line. So this portion is termed as an arc. Naming. How to name an arc? Children, there is one simple way to understand how to name an arc. We need a starting point, we need an ending point, and we need one intermediate point. How many points? 3. Starting, ending, and one intermediate point. So if I were to say, if this is my starting, this is my ending, I need one intermediate point. So say I'll say X. So say I'll say X. So how to name an arc? I shall say arc AXB. There might be one child who might be saying that, sir, who told you that A is your starting point? Even B could be your starting point. Agree? Agree. Then one can say it as arc BXA. No issues. So either you say arc AXB, either you say arc AXB, or you say arc BXA. You say arc AXB or you say arc BXA. What is the next thing we are supposed to learn? Say, for example, if somebody says, sir, what if there are further few points, say Y, say Z, then how we are going to? Say, for example, again, the definition or naming of an arc is the same. Starting point, ending point, any one intermediate point. So I have taken first X, I could have taken as AYB or arc BYA, or I will say arc AZB or arc BZA. Right, children? So this is how we go for naming of an arc. Let's go with the types of arc. What are the types of arc? There are two types of arc, children: minor arc and major arc. What are the two types? Minor arc and major arc. When can I say an arc is termed as a minor arc? When can I say an arc is termed as a minor arc? If the angle subtended by the arc, when I say subtended means form. If the angle subtended by an arc is at the center, mind you, angle subtended by an arc at the center, if it is less than 180, if the angle subtended means formed by an arc is less than 180, then it is termed as a minor arc. On the other hand, if the angle subtended by an arc is more than 180, it is termed as a major arc. So, what are the two types of arc? The two types of arc are nothing but minor arc and major arc. Minor arc and major arc. What is the answer? Angle subtended by minor arc is less than 180. So, less than 180. Major arc more than 180. So, can I say if this is a minor arc, the corresponding, say, let me say this is W, AYW, or for that matter BAWB, or for that matter BWA. I repeat, it's AWB, or for that matter BWA, will be termed as major arc. There are questions right now being raised from your side. Maybe some children are thinking in that direction. Sir, you said if less than 180, minor, more than 180, major. What exactly if equal to 180? If exactly equal to 180, then it's a semicircular arc. If exactly it is 180, then it's a semicircular arc. So if it is exactly 180, then it is a semicircular arc. Semicircular arc. Right, children? So we have seen the definition, naming, types. Now comes the formula. What is the formula for length of an arc? The formula for length of an arc is, L is equals to, formula for length of an arc is L. L is nothing but length of an arc, theta by 360 into 2 pi r. Formula for length of an arc is theta by 360 into 2 pi r. There are many who might think, sir, can't we cancel this 2 and 360? 2 1s are 2 180s are. So if you want, you can write down the modified formula also. It is theta. If I go on cancelling, 1s are 180s are theta by 180 into pi r. But we generally write down L is theta by 360 into 2 pi r. Why 2 pi r? Because arc is nothing but, I'm giving you the answer, why 2 pi r? Arc is nothing but a part of the circumference. When I say from here, point A, if I rotate completely and come back to point A, what have I gone for? I have gone for one complete circumference. And that's the reason the formula came into existence as theta by 360 into 2 pi r. So we always go with this. Ultimately, in our calculation, things will get cancelled. So I prefer this as a formula. Right? Once again, let's refresh. Definition, the length of the arc of a circle is the distance along the curved line. How to name it? Starting letter, ending letter, and any one intermediate point. Types of arc, minor arc, major arc. If the angles obtained at the center or angle formed by the end points of the arc form at the center less than 180, minor, more than 180, major, equal to 180, semicircular. And what is the formula? Theta by 360 into 2 pi r. On the same lines, let's define what is a sector. Now children, when I say sector, let's first understand the definition. The part enclosed by the two radii and their intercepted arc. So let's understand in the figure. Say this is my point O. Say this is my point O. Say this is the intercepted arc A, B. And if you want, you can say X. A, B and X. So let me say these are my two. I'll make this X proper so that you can see so. These are my 2 points and this is point X. Let's once again read the definition. The part enclosed by the two radii and their intercepted arc. So the part enclosed by the two radii and their intercepted arc. Arc AXB is termed as an intercepted arc. This portion is nothing but the sector. This portion is nothing but the sector. Right? I hope the picture is very clear. With this, now comes how to name it. Since it is the part enclosed by the intercepted arc and the corresponding two radii up to the center of the circle, so we say while naming it, it is sector O and then AXB. Why? Part enclosed by the two radii and their intercepted arc. So arc has to be there. But don't you think so? It's a region bounded, which has an presence of O also, where O is also playing a good major role. So it is this entire portion is termed as a sector. So we'll take O, whatever is a sector is what we are going to write down, O, AXB. Or for that matter, if you want, you can say O, BXA also, as we did for arc. Naming of an arc can be done in either ways. So center and then an arc name, center, arc name. Right, children? With this, let's proceed with the types of arc. Now, when I say types of sector, it is absolutely on the same lines. The answer is going to be major sector and minor sector. Major sector and minor sector. Now children, what I want you to understand is, on the same lines, here also, what did I said? If the angle subtended by the arc at the center less than 180, minor arc, same definition. If the angle subtended by the arc at the center, if less than 180, is termed as minor sector. greater than 180 termed as major sector, and equal to 180, then it's a semicircle arc. Major than 180, equal to 180, then it's a semicircular, not arc, but it's a semicircle. I'm sorry, it is not a semicircular arc, it's a semicircle. Minor sector, I'm so sorry, it is minor sector. I should have written down here minor sector. It is minor sector and major sector. Minor sector and major sector. Minor sector less than 180, major sector more than 180. Equal to 180, semicircle. Equal to 180, semicircle. If you want, you can write down equal to 180, semicircle. Now I want at this juncture, having made you understand, the third part is left, but these two, arc and sector, I want one interpretation from your end. Can I make one interpretation from our side that minor arc plus major arc will give me circumference? Minor arc plus major arc will give me circumference. So what is one interpretation? Let me say what is one interpretation. Minor arc plus major arc is nothing but circumference. What is the interpretation? Minor arc plus major arc is circumference. I want you people to again give me interpretation over here, but after I finish off the formula. Here we went for L is equals to theta by 360 into 2 pi r, and I made you all understand why 2 pi r, because it's a part of circumference. What is the formula over here? Area of sector. Area of sector is going to be theta by 360. Here it was circumference, that's why 2 pi r. Area is theta by 360. Here it is going to be pi r square. Why? Because it's a part of area, right? If I go inside, it is termed as area. So it's a part of area. That's the reason theta by 360 into pi r square. There is one more formula, children. There is one more formula, not derived from this one, but area of sector at times is also given by half into L into r. Now what is L over here? L is nothing but the length of an arc. L is nothing but the length of an arc, and r is nothing but the radius. So area of sector is also termed as half into L into r. At the same time, it is also termed as theta by 360 into pi r square. So those who are thinking, sir, when to use theta by 360 and when to use half LR, it's very simple. When length of an arc is given, you shall make use of this one. When theta is given to you, you shall make use of this one. Now I'm looking forward for the interpretation. What is the interpretation? Can I say minor sector plus major sector? Minor sector plus major sector is nothing but, if this is minor sector, but natural, this is going to be the major sector. If this is minor, this is major, what is the answer? Interpretation is area of circle. What is interpretation? Interpretation is area of circle. Are you getting me, children? Right? Let's move on the third part. What is the third part trying to say? Segment. What is the definition then? Segment is the region bounded by its chord and its corresponding arc. So how we shall go with? It is a region bounded by its corresponding chord, by its chord and its corresponding arc. So let me say there is a chord here. This is chord AB. Region bounded by its chord and its corresponding arc. Can I say this one? This is nothing but segment. How to name it? We generally use the same formula of that of arc. At times we go with two letters. If given third letter, we take it, but we will write down as segment AXB. Or if there are two letters, we do not prefer two letters for a simple reason. If somebody says segment AB, then mind you, if somebody says segment AB, it can be A to B, this one. At the same time, it can be A to B, so it will be this portion also. That's the reason we want one more intermediate letter. When I say AXB, that means I have to focus over here. If somebody said AYB, then it is this portion. Mind you, it is this portion. Again, it's a region bounded by the chord and its corresponding arc. Again, it's a region bounded by the chord and its corresponding arc. So we want segment to be written down, AXB or BXA, right? Now comes type. How we had minor, major, absolutely over here also minor and major. What is that answer going to be then? What's a minor segment? Minor segment. And what's a major segment? Major segment. Answer is the same. Answer is the same. If the angle subtended this by arc as well as chord. So can I say if this is what is the center? If this is what is the center, then the angles are subtended by the arc also. At the same time, you can say chord also subtends an angle. This angle, right? If the angle is less than 180, it's a minor. If it is more than 180, then it's a major. If it is more than 180, it's a major segment. What is the formula? What is the formula? Now, we will see the formula. I shall give you the derivation also. The formula for area of segment is general part. Formula for area of segment is area of segment is area of sector minus area of triangle. If I want to know this portion, the area of this portion, it is area of sector. So I'll show you outside, children, so that you can understand. Area of sector, right? Minus area of triangle. When I minus, don't you think so I'll be removing this portion? And what I'll be left with? Segment. Are you getting me? So what is area of sector? Area of sector is theta by 360 into pi r square. Theta by 360 into pi r square. There is one general formula. There are many who are thinking that area of triangle is nothing but half into base into height, or somebody will say herons, right? Somebody might go with right angle triangle also, because we don't know as of now what triangle over here it is. There is a general formula for triangle in mensuration only, and I'll give you the case when this is applicable. The general formula for triangle in mensuration is half r square sine theta. Half r square sine theta. Now I'm putting a star over here. Conditions apply. Nowhere you can take area of triangle as half r square sine theta. Only over here. What is the condition applied? The triangle should be within a circle formed by the radius of the circle. I repeat, triangle has to be within the circle formed by the radius of the circle. You cannot take my part statement. Sir, the triangle should be within the circle. So if here there is a triangle, can I say it is half r square sine theta? No. I said this area of triangle is half r square sine theta only and only when we have a triangle so formed by the radii of circle with the help of center, or you can say along the center. Then and then only I can say it's half r square sine theta. Now, what according to you? Can I remove common? Can I remove r square common? Can I remove r square common? If I remove r square common, children, if I remove r square common, you can see that here r square and r square is common. So if I remove r square common, the answer will be theta by 360, pi theta by 360, pi theta by 360 minus r square already taken outside, sine theta by 2. So I will say area of segment is nothing but pi theta, r square, pi theta by 360 minus sine theta by 2. What is area of segment? R square, pi theta by 360 minus sine theta by 2. I hope you must have understood how we have derived the formula. What is the interpretation? If this is minor, this is major. This was minor, this was major. Again, if this is minor, the corresponding will be major. So what is the interpretation over here? What is the interpretation over here, children? Come on, by this time you should. Interpretation is area of minor segment plus area of major segment. Again, it is going to be area of circle. Area of minor segment is equals to area of major segment. You can say so and understand also. Area of minor segment, area of major segment. If I club them together, what do I get? Nothing but area of circle. Absolutely on the same side. Area of minor sector plus area of major sector is area of circle. Area of minor segment plus area of major segment is area of circle. Right? Once again, reverse, completely revise it, and then only attempt any questions based on that.